Hi everyone, hope all of you are doing well. In this video, we are going to talk about confidence interval for a finite population. Let's look at this question. Look at here, question says 38 items are selected from a population of 400 items. We have a sample of size 38, but this sample is selected from a population of 400 items. Look at here, in this question, the population size is given because there are a limited number of items in the population. Here we have a finite population. Question asks me develop a 98% confidence interval for the population mean. When we need to make a confidence interval for a population mean and there are limited number of items in the population, I need to follow this rule. This rule says if we have a finite population of size n, uppercase N is population size, and we select a sample of size lowercase n from this population. If the ratio between sample size and population size is more than 5%, I need to adjust the confidence interval formula by FBC factor. Let's back to this question. Look at this question. We have a population of size 400. Then we select a sample of 38 from this population. Let's look at the ratio between sample size and population size. How much is the ratio? 38 divided by 400. 38 divided by 400 is 0.095. If you multiply this number by 100 to convert that to a percent, you get 9.5%. So 9.5% is more than 5%. Because the ratio between sample size and population size is more than 5%, I need to follow this rule. I need to adjust the confidence interval formula by the finite population correction factor, or FBC. But what is FBC? Look at here, that's FBC. Okay, I need to adjust the confidence interval by using FBC. Look at here, if we are going to make a confidence interval for a population mean, we have a finite population and the ratio between sample size and population size is more than 5%. So I'm going to use FBC in confidence interval formula. Okay, look at here. We suppose first population standard deviation is known. When population standard deviation is known, the confidence interval is x bar plus minus z alpha divided by 2 sigma over square root of n times FBC. Look at here, if you remember, sigma over square root of n is a standard error of the mean. I need to multiply a standard error of the mean by FBC, by this factor. And because sigma is known, population standard deviation is known, we are going to work with a standard normal distribution Z. X bar is sample mean, alpha is level of significance. For example, if we make a 98% confidence interval, alpha would be 1 minus 98% or 2%. What is Z alpha divided by 2? Z alpha divided by 2 is the Z value from the standard normal distribution, providing an area of alpha divided by 2 in the upper tail. Look at here, it's standard normal distribution. Okay, I'm looking for Z alpha divided by 2. Z alpha divided by 2 is a Z value on the upper tail. Okay, and this Z value provides an area of alpha divided by 2 on the upper tail, on the tail on the right side. The area on the right side of Z alpha divided by 2 under the curve is alpha divided by 2. The area of the shaded part, the area of the blue part is alpha divided by 2. And the shaded part is on the right side of z, alpha divided by 2. To find z alpha divided by 2, just in Excel, type equal sign, norm, period, s, period inverse. Because we have the area on the right side and we look for a z value, I need an inverse function, standard inverse function, okay? And this function just accepts the area on the left side. But I have alpha divided by 2, which is the area on the right side. Total area under the curve is 1. This function just accepts the area on the left side. The area on the left side would be 1 minus alpha divided by 2. Look at here. We have a situation like this one. It's z. Here is z alpha divided by 2. I know the area on the right side of this function, of this z alpha divided by 2 is alpha divided by 2. But to find z alpha divided by 2, this z value, I need an inverse function, norm, period, standard, period, inverse function. But this function just accepts the area on the left side of the point. Point is z alpha divided by 2. How much is the area on the left side of z alpha divided by 2? 1 minus the area on the right side, because total area under the curve is 1. Okay, so we can find z alpha divided by 2 by this formula. Sigma is given in the question, is known. N is sample size. Lowercase n, capital N is, uppercase N is population size. Okay, just I'm going to insert them in the formula to find the confidence interval. Look at it. We look for an interval. Any interval has a lower limit and upper limit. Okay, if it's limited. So the lower limit of this confidence interval is x bar minus z alpha divided by 2 times sigma over square root of n times FBC. That's lower limit. What about the upper limit? Upper limit is x bar plus z alpha divided by 2 times sigma over square root of n times FBC. What about unknown sigma? Sometimes we look for a confidence interval for a population mean. Population is a finite population. There are limited number of items in the population. Okay, I need to adjust the confidence interval by FBC, by this factor. But because sigma, population standard deviation, is unknown, in this case, instead of sigma, I'm going to work with S. S is sample standard deviation. And alpha, again, is level of significance. When sigma is unknown, instead of standard normal distribution, we are going to work with T student distribution, T distribution. T alpha divided by 2 is a T value from the T distribution, providing an area of alpha divided by 2 in the upper tail. Get here, T distribution is bell-shaped, but a little wider. Okay, so T alpha divided by 2 is a T value from the T distribution, and the area on the right side of T alpha divided by 2 under the curve is the area of the shaded part is alpha divided by 2. T alpha divided by 2 in Excel, just type equal sign T inverse 2 tail, then alpha n minus 1. If you remember, T distribution has a single parameter which is called degree of freedom. Degree of freedom is linked to the sample size. Here n minus 1 is degree of freedom for this T distribution. Let's back to this question. Let's go to Excel to develop a 98% confidence interval for this question. Look at here, it's the Excel file for the same question. We have a sample of 38 items. The sample size was 38. The population size was 400. The sample mean in the question was 37. Sample standard deviation was 2. Look at here in the question, we don't have population standard deviation. We have sample standard deviation in the question on the slide. And we need to make a 98% confidence interval. When we are going to make a 98% confidence interval, alpha would be 1 minus 98%. 1 minus 98% would be 2%. So alpha level of significance would be 2%. So to find FBC, I need a square root of population size minus sample size divided by population size minus 1. Divided by 2 can be found by T inverse 2 tail and then alpha and degree of freedom. Degree of freedom always is sample size minus 1. We have T alpha divided by 2. Now it's time to find the lower limit of confidence interval by this formula. X bar minus T alpha divided by 2 times sample standard deviation divided by a square root of sample size 38 times FBC. It's the lower limit of confidence interval. You can round that based on rounding instruction in the question. Okay? What about the upper limit? X bar plus T alpha divided by 2 times S sample standard deviation divided by a square root of sample size 38 times FBC. If you look for a confidence interval for a population proportion, if you need to make a confidence interval for a population proportion and the ratio between sample size and population size is more than 5%, again, I need to use FBC factor. Lower limit would be lower limit of the confidence interval for the population proportion using FBC would be sample proportion minus Z alpha divided by 2. What is Z alpha divided by 2? Z alpha divided by 2 is a Z value providing an area of alpha divided by 2 in the upper tail of the standard normal distribution. And you can find that in Excel by this function. Then, after finding Z alpha divided by 2, I need to find the standard error of the sample proportion. Okay, so P bar, it's sample proportion, times 1 minus P bar divided by N. N is sample size. Then multiply by FBC. 300 employees in a corporation. Population size is 300. They have selected a sample of 30 from this population. A sample of 30 revealed that 18 had graduated from a business school. Construct a 95% confidence interval for the proportion. Look at here. Here, because I have a finite population, I need to check the proportion between sample size and proportion size. Okay, it's 10% is more than 5%. So, because the ratio between sample size and population size is more than 5%, I need to adjust the confidence interval by FBC. Population size is 300, sample size 30. Okay, so From this sample, they have, from this sample of 30, 18 are graduated from a business school. The sample proportion, the proportion of the employees graduated from a business school is 18 over 30. Out of these 30 employees in the sample, 18 out of them had graduated from a business school. So it's sample proportion, P bar. Okay, so, and we need to construct a 95% confidence interval. Alpha would be 1 minus 95% or 5%. Alpha is 5% or 0.05. So let's go to Excel to make a confidence interval for the population proportion using FBC. We have a population of 300, a sample of 30. Out of these 30 employees, 18 had graduated from a business school. Alpha is 5%. First, let's find P bar. P bar is 18 divided by 30. It's the proportion. It's the proportion of the employees in the sample that are graduated from a business school. Okay. So I need to find FBC. So square root of population size minus sample size divided by population size minus 1. That's FBC factor. Now in the formula, I need Z alpha divided by 2 to this function. Norm, standard inverse, then 1 minus alpha divided by 2. So you can round this number to 2 decimal. Now let's find lower limit of the confidence interval. Lower limit is P bar minus Z alpha divided by 2 times square root of P bar. P bar is 0.06 times 1 minus P bar 0.06 divided by sample size 30, then multiply by FBC by this number. It's the lower limit of confidence interval. The lower limit of confidence interval is 0.4334. What about the upper limit? Let's find the upper limit. To find the upper limit of the confidence interval. P bar plus Z alpha divided by 2 times square root of P bar times 1 minus P bar 1 minus P bar divided by sample size n. Then multiply by FBC. The upper limit of the confidence interval would be 0.7665863. So we got the lower limit and upper limit for a 95% confidence interval for a population proportion when population is finite.